Genotyping and Antimicrobial Susceptibility Profiling of Streptococcus uberis, isolated from a clinical bovine mastitis outbreak in a dairy farm. In this short presentation, our goal is to offer you a quick summary of the research and conclusion. Please follow the links to review the research in further detail. Streptococcus uberis is an environmental pathogen causing about 1/3 of all intramammary infection, or IMI, cases in lactating and non-lactating cows worldwide. The pathogen has been increasingly implicated in clinical mastitis, or CM, cases in Europe. This paper presents a 4-month epidemiological investigation of Strep uberis CM cases in an Italian dairy farm. Although its primary reservoir is the dairy farm environment, some Strep uberis strains show a contagious transmission mode. Molecular genotyping contributes to understanding the modes of dissemination and can be useful in epidemiological studies of Strep uberis mastitis. A 4-month retrospective cohort study was undertaken to characterize 71 Strep uberis isolates obtained from CM cases at an Italian dairy farm. The genetic analysis revealed that Strep uberis mastitis cases in this herd could be linked to a relatively restricted number of cow-adapt strands grouped in the same genotypic cluster. In the present study, the genetic similarity of Strep uberis strands analyzed was evident in the PCR analysis, revealing that their virulence profile was characterized by a particular combination of genes that may be responsible for the high incidence of CM cases. The genes SUA, LBP, and PAUA could express potential adherence determinants enhancing the ability to cause clinical disease. The clear prevalence of a single RAPD cluster might suggest the predominance of a contagious behavior, although the environmental transmission should not be ruled out. Overall, the spreading of Strep uberis infections might originate from the exposure of the teat to the bovine reservoir, as well as a common environmental source, because of the ability of Strep uberis to persist in various spots of the dairy environment. The coexistence of these two modes of transmission might be the reason for the high number of Strep uberis CM cases within the studied herd. Control measures focused on the improvement of environmental hygiene may not be sufficient, and different management decisions can be recommended on each farm. The identification of strains likely to be responsible for cow-to-cow spread within a herd might help with the prevention strategies for the control of Strep uberis mastitis. The most common 81.7% resistance phenotype was for lincosamides and tetracyclines. The resulting increase of tetracyclines resistance in Strep uberis might reflect the environmental nature of this pathogen. Data suggests that macrolides, the third-line antimicrobial recommended for the treatment of Strep uberis infections, can be used in the herd as most of Strep uberis strands displayed an L phenotype. Overall, research found that 25.4% of the Strep uberis isolates had a multi-drug resistant phenotype. The study underlines the need to consider MIC50 and MIC90 values when making farm management decisions because the lack of breakpoints specific for mastitis pathogens. Genotyping and AMR results support the concept that few Strep uberis isolates might be prevalent in the dairy herd. strategies aimed to control contagious mastitis may be useful to reduce strep uberis spreading within the farm. In conclusion, strep uberis isolated from CM carried a combination of virulence genes that might be linked to strains with a greater probability of causing clinical infections.